Thank you for joining us at Excel Virtually Global. Next presentation will be Better Data Visualizations in Excel by John, where he will lay out the basic philosophy on how to expand the capabilities of Excel to create better and more effective data visualizations.
Hi, my name is Jon Schwabisch, and welcome to Effective Data Communication in Excel. Excel, as you know by attending this conference, is one of the world's most popular data and data visualization tools. And what I'm going to try to show you today is how to extend the capabilities of the tool to create better, more effective data visualizations. Because while there are a lot of options in the standard drop-down menus, there's a lot of ways that you can extend the capabilities of the program to create other types of chart types, like slope charts, dot plots, maps, waffle charts, lots of things that you can use. So my plan in this talk is to try to get you away from all this default terribleness that we all know and have come to love/hate in Excel. All those 3D things, the 3D exploding pie charts and bubbles and ribbons and all that stuff. We don't want to use that. What we do want to do instead is to create better, more effective visualizations that sort of extend the capabilities of the tool. So for example, in the 4 visualizations you see on the screen here, none of these can be created by default in Excel. The graph on the top left is a pretty standard area chart, but what I've done here is I've colored the positive areas differently than the negative areas on the graph, something that you can't do by default. The graph on the top right is what's called a mosaic chart. So it's your standard stacked column chart or stacked vertical bar chart where the pieces sum to 100%. But also, I've changed the width of the bars to correspond to a second variable. Again, not something you can do in Excel by default. And in the bottom right, those are 2 overlaid histograms where I have an outline around the outside of the histogram so you can sort of get a better view of it, and then they're layered on top of one another. And then finally, the chart on the bottom left is your sort of standard, congressional parliamentary seating graph, where we have here in the United States the breakout of the US Congress into Democrats, undecided, and Republicans in red. Now, when I look at a graph like that, what I don't see is some sort of chart type that I can't make in Excel because it's not in the drop-down menu. What I instead see is a scatter plot with 435 circles arrayed around several rings of several semicircles. So to create this in Excel, all I really need to do is figure out some trigonometry to place each of those circles on the rings of each of those semicircles. And once I have that, it's just a matter of aligning it and arranging it, because all I really need is a horizontal axis and a vertical axis and a little bit of math, which admittedly is not the easiest thing to do in the world, but anyone can really figure that out. So what I'm going to do in this talk is bring you through 4 pieces of creating better data visualizations in Excel. I'm going to start by talking about meeting Excel where it is. Excel is just a tool. It's not better or worse than any of the other data or data visualization tools out there. It is what it is. And I wouldn't use Excel to create an online interactive visualization on the New York Times website, but I will use it for most of the work that I'm going to do day to day. I'm going to talk about changing the defaults in Excel for our data visualizations, both within specific chart types, and then how to create a custom color palette in Excel. I'm going to talk about how important it is and how to encode your data on your charts to add annotations and to make your graphs more scalable and more reproducible. And then finally, I'm going to show you a couple of examples of how I pull all of this together with some relatively simple data. So let's start with meeting Excel where it is. As you know, there are lots of data visualization tools out there. And I can like to think of tools running along this spectrum of what I call barrier to entry. So tools along the left side here where you can see Excel, Data Wrapper, Google Sheets, those sorts of things are primarily drag and drop based or click based, right? These are the things you have a fairly finite library of graphs, but they're relatively easy to use. Anyone can open Excel with a data set and insert a line chart right away. On the other side of the spectrum are tools that are more flexible. They also have a higher barrier to entry. So primarily, I like to think of these as programming languages like R, D3, and Python. The only limitation in these tools of what you could create is how good you are and how imaginative you are with your coding. Of course, to get to that step is a big barrier to entry. So it is harder on that end of the spectrum to get into a tool, but once you're in there, it's basically an infinite space, as opposed to the tools on the left of this slide that have a more finite space, but are easier to use in many ways. And my goal with Excel is to try to push it as far as I can along the right edge of the right space of this spectrum, so that I can make it more reproducible and more scalable, so that when I share my Excel files with people, all I hopefully will need to do is just update the data and the chart will update automatically. And we're going to get to that in just a little bit to show you how I go about doing that. So you all know the basic menus in Excel, all the basic formatting menus, the styling menus, the different types of charts that you can use. The thing to keep in mind when you are trying to create better, more advanced visualizations in Excel is that Excel has primarily two philosophies, two pieces to it in its underlying structure of how it creates visualizations. The first is it works in fairly simple shapes: lines, bars, and circles. And I should say also that these are non-trivial lengths of each of these shapes or sizes of each of these shapes. For example, if I wanted to make a map of the United States in Excel, not accounting for the newer menu, the newer mapping engine, but if I wanted to make one custom, it'd be really hard to do, because getting a curve, for example, on the coast of Florida would be really hard to do in Excel, because it's not a non-trivial length of those lines. But if I have non-trivial shapes that are lines, bars, or circles, that may be something, probably something, that I can create in Excel. The second thing I need to recognize is that Excel works in an XY space. It's a two-dimensional space. The three-dimensional is not a real dimension. It is a perspective rendering of 3D. So it's not actual 3D. So we have two dimensions: horizontal axis, vertical axis. And in some cases, many cases, when we're trying to expand what we can do, we have secondary vertical and horizontal axes. So if we're working in that XY space and we're using lines, bars, or circles, it's probably a visualization that we could actually create in Excel. So take, again, this congressional parliamentary graph. Again, it's working with circles. So it's achieving our first philosophy, our first goal. It has one of those shapes. And then secondly, we are working in an XY space. I've got a vertical dimension and a horizontal dimension. And all I need to do is a little bit of math. Again, not saying it's easy, and not saying that I didn't have to do a lot of research to figure out the trig here. But once I can figure that out, I can place those circles along the circumferences of those semicircles to arrange the graph the way I'd like. Now, I'm going to remind you again that it's just a tool. Excel is no different than D3, JavaScript, Python, Data Wrapper, Google Sheets, all these other tools. It is just a tool. And there are pros and cons to all of these tools, but I'm not going to use Excel for certain things that it's not intended for. I'm going to use it for my everyday graphs. So let's talk about changing the defaults. One of the things that I really stress to people when I'm working with them on their data visualizations is don't rely on what the defaults are in the tool. We want our graphs to stand out. And one way we can do that, if we're working in a tool like Excel, is to not use the defaults, not the Calibri font, not the basic colors. And when we make a standard chart like this, so this is a line chart of the unemployment rate in the United States from 2007 to 2020, you might think, this is a pretty simple graph. There's really nothing to it. Just insert a graph and you're on your way. But there's a lot going on behind the graph. Take an extra second to see what's here. And all these things are things that we can't control. There's the text inside and outside the graph, the title, the subtitle, the sources, the notes above and below the graph. We've got the axes, both the vertical axis and the horizontal axis. We can control whether a line is there. We can control its color, its thickness, its shape. We can control the tick marks and the labels and where they're going to place and how frequently they're placed and their size and their font and their color. And then when we get inside the graph, we can control the color and the thickness of the grid lines and their style. And of course, whether we're going to include the data labels and the data markers and what they're going to look like. And then finally, in the data itself, we can control the color and the thickness of the line, color of the bar, size of the circle. These are all things that we can control in our charts in Excel. And these are all things that we should control in our charts in Excel, rather than just letting Excel dictate its defaults to us. So I'm not going to go through, obviously, every menu. That's going to be a waste of all of our time. But I just want to show you that there are multiple ways to achieve the same goal, thinking about some of these different menus in Excel. So for example, let's take that graph I just showed you. And let's say I want to change something about the grid lines. I want to change their color. I want to make them dash. I want to make them thicker, whatever I want to do. So one way to do that on a PC, and a lot of what I'm going to talk about today is going to extend both to PCs and Macs. Some slight differences, but mostly will be fine on PCs. One thing I can do is I can select the chart. The design tab will open up. I can click that. I can go over to the far left, hit the add chart element button. I can go down to grid lines and I can select the more grid line options. A lot of clicks there to get to the format grid lines menu. And once I'm there, I can play around with the size and the shape and the color, et cetera, et cetera. Another way I can achieve the same goal is to right-click on the grid lines and select the Format Grid Lines option, and I'll get to the same Format Grid Lines menu. But another way to do this is to use a keyboard shortcut. And I'm sure many of you use keyboard shortcuts all the time in Excel. You know how to use the Alt key to navigate through all the menus. I can't do that. I don't have the brain capacity to do that. Of course, I do know Control S for save, Control C for copy, Control V for paste. Control 1 is the other keyboard shortcut that I know that is just like C, S, V, P, all those other standard shortcuts, because Control 1 or Command 1, if you're on a Mac, will bring you directly to those formatting menus. So if you want to format your grid lines, select your grid lines and hit Control 1 or Command 1. You want to format your horizontal axis, select it and hit Control 1. You want to format the cells in the spreadsheet, select them and hit Control 1, and it will bring you to the Format Cells menu. So that keyboard shortcut is really, I think, important to be more proficient and being faster in your data visualization work in Excel. The other thing to note is that there's a lot going on in the various menus. And again, I'm not going to walk you through all the various menus. It's something you sort of learn and find as you're working more and more with Excel. But I did just want to highlight this one really neat menu in the Format Axis tab of Excel. Let's say you have monthly data and you want to change the increments of the labels and or the tick marks along that axis. If you go into the Format Axis menu, there's a little area called Units. And here you can change, again, the tick mark, the frequency of the tick marks and the labels. For here, for example, in the red circle, I've changed the units from 1, which shows every month, to 12, where it just shows every 12 months, just the first month of the year. So instead of having to go back to my data and create an entirely new column with entirely new frequencies of the x-axis labels, I can actually do this in the built-in menus in Excel, which is going to save me a lot of time, save me a lot of effort, and make it more reproducible and scalable down the road. So let's go back to our unemployment rate chart. So we're going here from January of 2007 to January of 2020. We've got this blue line going up and then coming right back down. Well, notice also that I've got for each year 3 months that are being shown along the x-axis. And Excel is basically going to decide how many labels it's going to include based on the size of the chart. So here I've sized it such that I've got 3 labels for each year. A little bit weird, probably don't need that many. So what I'm going to do first is go into that Format Axis menu, and I'm going to change the major units to 12. So now I just have January of each year plotted along the horizontal axis. Now, having JAN and that hyphen repeated each year, probably not the best use of my time, doesn't really look great, don't really need it. So what I could also do, instead of going back to my spreadsheet, is to format the numbers along the axis. And again, I can do that in that same Format Axis menu. And here I'm going to use the custom dropdown, where instead of just using what the number is or what the text is, I'm going to type in a custom code, Y, because I have the date being used here. And so if I use the 4-letter Y combination, it's just going to show the year, the 4 digits of the year. So here I've gone from this weird Jan 2017, Mar 2017, Sep 2017 to just 2017 that marks the first month in the year. So that's another way to go about formatting, in this case, the axis of your chart without having to go and change the actual data in your spreadsheet. Now, before we move on, I just want to show how to change your colors and create a custom color palette. And I find this especially useful for groups and teams and organizations, but it's also really useful for me as an individual, because when I'm working with Excel and I want to use a custom color palette, and I want to use that same custom colors palette each time, I don't want to have to do that manually. It's just a lot of work to have to change each line and each bar and each series time after time after time. And creating a custom color palette in Excel is really, really easy. So I'm going to show you how to do this on a PC. It works the same on Macs, but for some reason you have to do it in PowerPoint. Okay, so if you're on a Mac and you want to create your own custom color palette, you need to do it in PowerPoint. But however you do it, it's going to load in all of your Microsoft Office tools, Word, PowerPoint, Excel, and so on. So in Excel, if you're on a PC, what you're going to do is you're going to go to the Page Layout tab. You're going to go over to the Colors button, and you're going to hit that button, and you're going to see a list of additional color palettes. Now, I will say, for whatever reason, these color palettes are probably worse than the standard Office palette. I don't know why they didn't say, let's make a better palette in here, put them in here. But okay, so they have all these other color palettes. You can see them here. There's blue and blue-green and green yellow, et cetera, et cetera. But at the bottom of this menu, as you can see, I've circled it here in the screenshot, is a customized colors button. So what you're going to do is you're going to click that customized colors button, and you're going to get this little pop-up menu. And this pop-up menu is going to enable you to change the colors in your default palette. So you can see at the very top, we have two options, two sort of classes of the text versus the background. So dark 1, light 1, dark 2, light 2. Then we have 6 accent colors, and then below that are the hyperlink colors for a hyperlink and then a followed hyperlink, which I never change. Blue, purple tends to be how we use it. But the 6 accent colors, that's the important part, because that's going to enable us to change the default colors in our use of Excel. And the order here does matter. So in my default Office color palette in Office 365, if I create a line chart with just one line, that line is going to be colored blue. If I add a second line, that line is going to be orange. Third line is going to be gray, and so on and so forth. And you can see in the sample there on the top right, that's how the chart's going to look. And it's going left to right from the first accent color to the 6th accent color. So if you want to change these accent colors to your own brand, to your own palette, just think about how you want your charts to look. For example, if I go to the Urban Institute Style Guide, which is an open resource, the Urban Institute is a nonprofit research institution based in DC. Their style guide is hosted on GitHub, and it's open for anybody to use. Their primary color is this blue color that's right above me right here, this sort of teal blue color. So a graph in Excel that has one line is going to be in this blue color. The second line on that chart is going to be in this gray color. Then it'll be a black, then a yellow, and so on and so forth. So when I enter these colors into the custom color palette generator in Excel, I'm going to use those accent numbers in order so that you can see here, I'm going from the standard blue in Excel to this lighter blue in the Urban palette, from orange to gray, from gray to black, yellow to yellow, blue to pink, and green to green. Now what I do is I name that custom color palette in the name box where it says custom 1, and I click save. And what's going to happen is Excel is going to generate all the tints and the shades in that menu. Now, unfortunately, we can't control the tints and the shades, so you're sort of stuck with how it generates it. But as you can see here, you've got a whole bunch of tints and shades that you can play with. And now we can go back to our Page Layout tab, hit that Colors menu, and the Urban Institute color palette is going to show right up. And so now when I create a chart in Excel, I've got my standard colors. These are standard colors in Office 365. All I have to do is go to Page Layout, Colors, and hit that Urban Institute color palette, and they're going to change automatically. So this is a great thing because now I don't have to do this manually for each of these bars for all of my graphs. I can just do it by default. And the other great thing is I can share that palette with other people in my organization and my team. Now, how do you find that file? So when you click Save and it creates that custom color palette, it's going to save it as, in my case, urbaninstitute.xml. And it's going to save it all the way in the guts of your computer under Program x86, Microsoft, Themes, Theme Colors. There's a whole thing you have to go to find it. I never remember where it is. So the way I do it is I create some sort of dummy custom color palette with a name that I know I'm never going to need to use. For you, you might want to use Schwabish. Probably doesn't show up on your computer much, right? Then search for that file, schwabish.xml. Then you can go in, you can change the name of the color palette or create the color palette now that you know where the folder is. And then what you can do is take that XML file and share it with your team members. And then they put it in the correct folder on their machine. When they reopen Excel or reopen PowerPoint or reopen Word, that color palette's going to be sitting right there and they can use it. So now if you and I want to have the same exact colors and not have to redo it manually each time, we can do it on our own machines simply by selecting that button, selecting the page layout, colors, and our color palette button, and our colors are going to update automatically. So that is one easy way to go past the Excel defaults and make your life a lot easier rather than having to do this by hand each time. Let's talk about encoding the data. And this is where I'm trying to take Excel and push it as far over as I can, closer and closer to programming languages. I'm trying to make the Excel graphs more scalable. I'm trying to make them more reproducible. I'm trying to make them ultimately easier to update and create. So let's go back to another unemployment rate graph. It's a little bit shorter this time, from 2007 to 2018. And let's say I want to add labels just like this. I want to have the unemployment rate in the first month of every year on my chart. Now, when I ask people how they would do this, they say, well, I would insert the chart, I'd insert my line chart, I'd select the line, I'd right click, and I would say insert data labels, which of course is the way most of us would do it. But I think we all know that when we do it, we get something like this. And so what Excel does by default is it adds the y-axis value, the y value, to the right of each of these points. So what you have here is 110 different data labels. And so if I wanted to get the data label just for January of each year, what I have to do is select the labels. Then I have to select February of 2007, right? That second data label. I have to delete it. That's select March of 2007 and delete it. April of 2007 and delete it, and so on and so forth. And if I make a mistake, I have to start all over again. I can't just undo delete by delete by delete. I have to start all over again. So it's a really ineffective way to do this. Also, if the data change, or if I want to extend the data for another month or another year, whatever, I have to do that all over again. It's just an inefficient way to do something that's actually quite easy. So I'm going to show you how to do this very simple task of adding labels of the first month in each year by simply creating another line to add to this chart. So here's my spreadsheet that has my data. I've got the month in text in column A, the year as a number in column B. I've got the month as a number in column C. I've got the date in column D, and I've got the unemployment rate as a number in column E. So this is the data. This is what I've used to create my basic chart. Now what I'm going to do is I'm going to create a new series, a second unemployment rate series that I'm going to use to actually add the labels. And I'm going to do that by using an if statement. And if you're a regular Excel user, you probably know how to use an if statement. If not, I'm going to show you. It's quite simple. An if statement in Excel only has 3 arguments, okay? There's an evaluation, so we're going to see if this is greater than some other number, if this is equal to something, if this is less than some other, whatever the evaluation is. If that evaluation is true, the second argument in the if statement is going to say, what do we do if the if statement is true, if the evaluation is true, right? If the number in the cell is greater than 100, what do we do if it's true? And that's the second argument. And the last argument is, what do we do if it's false? And so in this particular case, we're going to create a new series. And so in cell F2, I have a very simple if statement. It says if C2 equals 1. So C2 is the month, the number of the month. So if cell C2 is equal to 1, so if it's January, if that is true, give me the unemployment rate, right? So if C2 equals 1, give me the unemployment rate, which is found in column E. If it's not true, if it's false, give me an NA, okay? And here I've written it in the if statement as NA, open parentheses, close parentheses. And I'm going to copy that formula all the way down. So you can see here in row 2, I get 4.6%, the unemployment rate. In row 3, in February of 2007, the evaluation is false, and therefore I get an NA. And you'll notice that Excel has rendered the false statement here as hashtag NA. Come back to that in a second. Pull that formula all the way down. You can see in January of 2008, I again have the percentage, the unemployment rate, it's 5%, and then a bunch of NAs. Now, why NA? Well, what Excel is going to do when it has NA in the chart is it's just going to ignore it. It's just going to use it as a blank. And this is different than if I use a 0 or if I use a space, because a space is then text. But in NA, Excel is just going to ignore. So now what I'm going to do is I'm going to put on my chart column E and column F. And so now I have 2 lines. And so you can see I've rendered this here in the combo box. If you're a PC user, you're probably familiar with this. I have the orange line is going to be all of the months, all of the data. And then the blue dots are my second unemployment rate series, my new unemployment rate series. And so what I get here is just January of 2007, January of 2008, January of 2009. And in between, Excel sees NA, so it just ignores those particular points. Notice what happens if I had changed that if statement, that instead of the false being NA, it was 0. Excel renders the first row 2, January 2007, is 4.6%. Then in the second row in February, well, that's 0. So then it drops down to 0. You get 0 for 11 months, and then it pops back up to 5%, and then right back down to 0. So you get this crazy looking graph. But if I have those NAs, it ignores those 11 months in between. I have my dots here. I can right click. I can add data labels just to those dots. Now I have just the labels in each January. Then I can hide those markers. I can turn them off. And now I've got my chart. Now, maybe here, right, this isn't quite done, right? That 9.1% right off the peak is kind of hidden by the line. The 7.8% is hidden by the line. I might want to make some changes, might want to move these around a little bit. But of course, if I was doing this in R or D3 or Python, I'd have to do the same thing, right? I have to move those labels around and change the pixels. And so here I can do that in Excel. So I haven't really moved that much further from a coding world like R because I have created a second series that is built off of the first series. And so now if I went back into my original spreadsheet and updated that to GDP or updated to poverty rates or updated to any number that you could think at a monthly level, my data is just going to update. I'm going to have a whole new chart without having to really do anything to it. Now that you've seen that, let me tie this together with a couple of examples. I'm going to show you the hardest one first. This is called the Raincloud plot. And so what a Raincloud plot does is it's essentially a box and whisker plot. And so each of these boxes here show you the 25th and the 75th percent at the ends, and then the median in the middle. And then the whisker is the line that comes out from, in this case, I put it at the bottom, shows you the 10th and the 90th percentile. But I'm also showing you all of the actual data values. And this is from a basic data set that's used in R a lot to do some testing. So I'm actually going to put all of these dots on the graph so that you can see not just the summary numbers, the summary statistics, but also that so you can see all the actual data points. Well, again, can I make this in Excel? Do I have one of my key basic shapes? Yeah, I've got actually all three here. I've got lines, I've got bars, and I've got circles. Can I make this in an XY space? Sure can. I've got a horizontal axis here going from 4 to 9. And then I've got a vertical axis where I've got my labels, and then I'm going to have each of the different Raincloud plots. So here, all I've done is combine together a stacked bar chart. So I've got the this new light blue that you see here. I have that on there to build the space, and I hide that. I'm going to put that with no color. Then I've got two stacks for the first bit between the 25th and the 50th percentile, and then another stack between the 50th and the 75th percentile. The rest, how am I going to add the rest? I'm going to use a scatter plot, right? I'm going to use a scatter plot to place all the points, right? I just need to figure out a little bit of math and organization to figure out what is the X dimension, that's the value, and what is the Y dimension, so I can place these points on the graph. And so you can see here, I'm going to place one dot at the 50th percentile. I'm going to add error bars. I'm going to put it out to each the 10th and 90th percentile. That's how I get that line. And then I'm going to add each of these sets of orange, green, and blue dots on the graph just using a scatter plot. And you see here, this is what my spreadsheet will look like. You can see that I've got Y's and X's for each of my three series in columns A, B, C, D, E, F. And then in columns H through L about, in those first couple of rows, I've got everything sort of organized. I like to use color in my spreadsheet because, again, this is not a coding language, so I can't necessarily just click run and it's going to compile and run the whole program. But if I use color and organize the sheet, when I come back to this in a month or 6 months or a year, I can basically figure this out again because it's sort of organized nicely in my spreadsheet. I'm going to show you one more example. This is from the National Center for Education Statistics here in the US, and I'm going to zoom in so you can see more of this data. This data set has data for every state in the United States. It's the average starting time for public schools in the 2017-2018 school year. So in the first column, we have the name of each state. In the second column, we have the average starting time. So in Alabama in this school year, public schools started at 7:49 a.m. on average. In Alaska, they started at 8:39 a.m. on average. Arizona, they started at 8:14 a.m. on average, and so on and so forth. And the other 5 columns is the percent distribution of these different start times. So we have, some set of schools start before 7:30, another set of schools start between 7:30 and 7:59 a.m., and so on and so forth. I'm going to focus just on this start time, just on this the second column with the average start time. Now, if I gave you just this column and I said, hey, here's some data, it's the average start time for each state in the United States, make some graphs. My guess would be your instinct would be to make a map. And there is a newer charting engine in Excel that allows you to make maps. Notice that it's different than the classic insert chart menu, and that's because it doesn't use the fundamental lines, bars, circles of a particular length, right? And so here we actually can create a map in Excel using that new engine. I particularly am not a huge fan of this. I will say it's better than some other tools, but it is pretty limited in what sort of geography you could use. But I tend to kind of use it, but not always. But you can see you make a pretty decent map here. We can also make other maps that are not your standard sort of choropleth map. We can make what are called tile grid maps. This is made just in Excel. And again, why? Because I've got squares and I've got an XY axis. And here, each square represents a state. I've shaded them in based on their average starting time, the earliest schools in the light green, the latest starting schools in the dark green, and each state has its abbreviation. And I can do that right in the spreadsheet. I could also change this if I wanted to show the time, the starting time, the actual starting time, rather than the abbreviation of the state. Again, it would depend on the audience and how familiar they are with the geography of the United States. So that's one way that I could visualize these data, actually using the geography and actually showing you a map. Another way that I can do this is to create your standard bar chart, right? So here I've just got the bar chart sorted from latest starting to earliest starting. But maybe that's too much ink and I want to actually just create a dot plot here. Well, again, let's go back and think about what I can use. Lines, bars, and circles. So here I've got circles and I've got an XY space. So along the X dimension is the actual time. And of course, Excel is going to render that time, 8 a.m. is an actual number. So that's fine. So I've got that along the X axis. And then the Y axis here is actually just going to be a simple counter. Excel doesn't care what type of number, what type of data I'm using in the chart, just as long as it's a number. So in this graph, at the very bottom, we have Mississippi. So Mississippi starts, it looks at about, 7:47 a.m. on average. That's the X dimension of the scatter plot. The Y dimension for Mississippi is 1. The Y dimension for Alabama is 2. The Y dimension for West Virginia is 3, and so on and so forth. So I just have a ticker here from 1 to 51 all the way up, tagged with the data values. And now I have a little dot plot. And I can take that another direction if I want. If I want to make a lollipop chart, I just add a line that goes from left to right from that first point, from those points all the way to the Y axis. What about the distribution? Well, let's say I want to focus on the distribution of these data. I could create a histogram. Now, the Office 365 version of Excel does have a histogram built in. So you don't even really have to do any math to figure out what the distribution should look like. You can just grab your data, insert histogram, and you have it. You could also do this if you figured out your bin widths. You could also create this. It's obviously just a standard column chart. But I can't see where my state is in this distribution, right? I live in Virginia in the United States. I don't know where my state sits in this distribution. Well, I could actually show that. I could actually use the names of the states in my chart, right? And so here again, I have, in this case, I'm going to use data markers. I'm going to use squares that I'm going to ultimately hide. So it doesn't really matter what the shape is in this case. But I'm also going to use my 2 dimensions. I've got a horizontal axis here. I've got 1, 2, 3, 4, 5, 6 dimensions, 6 areas along the horizontal dimension. And then I've got my counter 1 all the way up. It'll be up to 13 along my vertical dimension. So let's take a look at where my state is in this space in Virginia on the second to last column. You can see that Nevada, the X dimension for Nevada is going to be X. The Y dimension is going to be 1. For Utah, the X dimension is going to be 5. Y dimension is going to be 2. Idaho 3, Montana 4, Virginia, the X dimension is going to be 5, the Y dimension is going to be 4. And if I arrange my data in such a way where I don't have to I set them up into these 4 groups by the region of the United States, I can actually just select my labels and color them all at one time rather than having to do this manually. I could also use icons if I want to have some fun. There's a great font called Stateface from ProPublica that will allow me just to use letters as my labels, and then I can convert that to the Stateface font to add icons. Not sure this really works all that great. Like Montana and Wyoming, the shape is a little similar, so may not work so well. But as you can see here, I can do multiple things with this. What about embracing the idea of time and just creating this as a clock? Either as 2 clocks, one for the states that start at 7 a.m. hour, and the other for the schools that start in the 8 a.m. hour. Or I just push them together into a single clock face. Again, I'm using one of my shapes of lines, squares, or circles. I'm using an XY axis. How am I using an XY axis here? Well, again, need to do a little geometry here, right? You're going to need to look up a little geometry. But if you put this in a space, you can just figure out that this is just a series of circles. The clock face itself is a circle of some radius, right? Then there's a circle that's slightly bigger, has a slightly bigger radius. That's going to be the first ring of state abbreviations. Then another circle that's a slightly larger ring of abbreviations. And then I just need to figure out how to convert my times to these points around the circle. Again, just using a little geometry. You can see here again, here's my underlying spreadsheet. You can see that I've arranged all the data around using different colors so that when I go back to this and I update the data, if I update the data with the 2020, 2021 school year, everything should update almost automatically. It's not going to be perfect because, again, it's Excel. It's not a coding language. It's going to work almost automatically, and I can update this graph quickly and easily. So as you can see, with this very simple data set, there are multiple ways to visualize these data. It doesn't always have to be a map when you have geographic data. And you can see all these graphs, completely non-standard in Excel, not in the drop-down menu, but that I can create in Excel simply by acknowledging and realizing the underlying philosophy, that it uses these core shapes, lines, bars, circles, and it works in an XY space. If you'd like to learn more about data visualization, about communicating your data, either on your actual data visualizations or on your slides, or more generally, check out 3 of my previous books, Better Presentations, Elevate the Debate, and Better Data Visualizations. And if you'd like to learn more about creating better charts in Excel, look out for my new book coming out in spring of 2023, Data Visualization in Excel, where I'm going to show you, where I walk you through how to make these and many other graph types in Excel. I hope you'll check it out when it comes out this spring. So thank you so much for tuning into this talk. I want to remind you one last time that Excel is just a tool. It's no better, it's no worse than many of the other data and data visualization tools that people use. It is designed for certain things. It is not designed for me to create complex, interactive data visualizations that would live on a website at the New York Times, the Washington Post, or somewhere else. But we can take that tool and we can extend it and expand it, create better and more effective visualizations simply by understanding what it can and what it can't do. So I hope you'll follow me and connect with me at Schwabish on Twitter, at policyviz.com, and be sure to check out my new book on data visualization in Excel when it comes out in spring of 2023.
Thanks very much, John. That was Excel is just a tool, apparently. That was Jon Schwabish's session there at 4 a.m. UTC. Welcome to Excel Virtually Global.